This is air, which is a rarer medium, and then if you have water, which acts like a denser medium. Now, this is how the depth to which the water is. If there is anything which is over here, for example, this is a point A, but when viewed from a rarer medium, okay, when it is viewed from a rarer medium, it appears to be raised. Instead of being at the original position where it is, the object seems to be over here. So this is due to refraction of light. And we are going to see how this works. So object which is at its original position, when it is in a denser medium and viewed from a rarer medium, it appears to be raised. And that is due to refraction of light. And we are going to do a small derivation today. So this is air, and this is a denser medium, let's say water. And the denser medium is till this point. So that is the reason why I'm going to call this as a real depth. Okay, or the actual depth. And this is the point in consideration. So let's say this is a point, and let us label this point as O. Now I'm going to take two arrows coming from that point. So one arrow is like this, going straight. Now this arrow is incident perpendicular. Now since it is incident perpendicular, it is going to go undeviated. And I'm going to draw another arrow, which is this way, okay, which is at an angle like this. Now we know that this object O will be appearing over here. So I'll call this as O dash. So this is O dash over here. That means this ray of light, okay, let me draw a normal also. So when we are drawing a normal at that point of incidence, okay, so the refracted ray goes like this. And it is very clear that you can notice that there is bending of light. Okay, so the direction in which the light would have otherwise gone straight, if I extend this arrow, I can show you that. See, this arrow extend like this way. But here you can see that the other arrow that I've drawn is bending away. So, fine. Of course, when you bring the arrow back, we have to show this arrow as dotted. So I'm showing it dotted. This ray of light, which is making an angle of incidence with the normal over here. So that is called as angle of incidence. And over here, that is angle of refraction. Okay, fine. So air and water. Now, this is 90 degree. This is also 90 degree. And that is the reason why I can get this angle also as I. If you have a line over here and there are two lines perpendicular to it, like this, then this acts like a transversal. So this angle is equal to this angle. That is called as interior alternate angle. And similarly, we get R, this also as R. So how you get that? So which is called as a corresponding angle. So if you don't consider this line, this line if you consider, because they are parallel to each other. So this angle is equal to this angle. Okay. So that is R and that is I. Now I want to make one point again over here. This is medium 1, this is medium 2. A ray of light is entering from one medium into medium 2. So the angle of incidence in medium 1 is called as angle of, the angle is called as angle of incidence. This is called as angle of refraction. So therefore, this is called as refractive index of second medium with respect to first medium. So that is sine I upon sine R. Okay. So therefore, if you are talking about refractive index of water with respect to air, so this will be sine of I upon sine of R. Now I should be in air and R should be in water. The angle of incidence must be in air and angle of refraction must be in water. Okay, so with this information, if I write down over here, refractive index of water with respect to air. So as I told you, angle of incidence must be air. So therefore, I will write over here sine of R and then I'm writing sine of I. Okay, so remember that. So if I place a mirror like this over here and allow the light to go back, then we are going to get the same answer. So if I allow the light to go back like this and like this, so then this is going to be I and this is going to be R. So there is nothing different that I'm making. Now with this information, let us go ahead. Now what is sine of I and sine of R? So for sine of R, I'm going to consider, let me name this as B and name this as A. I'm going to consider triangle AO dash B. Now in this triangle AO dash B, okay, what is sine of R? It will be opposite side upon the hypotenuse, that is O dash B. Now in triangle AOB, that is this big triangle over here, I'm going to take sine of I, and that will be AB upon OB. So therefore, sine I upon sine R, I get AB upon O dash B divided by AB upon OB. Now when the division turns into multiplication, so this will become O dash and this will become AB. So that get cancelled and you have OB upon O dash B. This is refractive index of water with respect to air. Okay, so this is what we have got so far. Now what I'm going to do, I'm going to say that OB is approximately equal to OA and O dash B is approximately equal to O dash A. Now why do I say that? Students, in reality, in practice, suppose the water that we are talking about, it is a fish tank. So say for example, this is a fish tank and this is point O. So the rays of light that are coming, which you are observing, those two rays of light are pretty close to each other. That means these rays of light are pretty close, like this. They are so close because this will be your eye. Okay, so this gap is in millimeters, whereas this gap is in some like 2 feet, 1 feet. If it is a swimming pool, that will be in meters, and if it is something like a pond, it would be like few meters. So that is the reason why I am saying that OB and O dash OB and OA is equal in length. O dash B and O dash A is equal in length. I'm going to write refractive index of air with respect to water. I'm going to write it as OA and O dash A. But look over here, what is OA? This whole length. That length is called as real depth, okay? And O dash B, this length is called as the apparent depth. So this is a formula based on which we will be doing the questions. This is a real depth, okay? So let me call that as X. And here, this is the apparent depth. Let me call that as Y. So I have refractive index as real depth upon apparent depth. Now shift means a point which is here appears over here. So this is called as a shift. So this shift is X minus Y. Okay, that is the real depth minus the apparent depth. And Y, I am writing it as X upon the refractive index. So this is X upon refractive index. So I take X out and I get 1 upon the refractive index. So the shift is real depth 1 minus the refractive index. Shift depends upon the real depth. It depends on refractive index. So more shift, that is more thickness, more shift, more refractive index, more shift. And it also depends on the wavelength. We know that shorter wavelength means more refractive index. So therefore shorter wave shows more shift. And therefore, if you have a block of glass, okay, and below the glass you have a printed paper, and printed paper have some letters written on it. So letters like, say, something is written in red, something is written in green, and something is written in blue. Okay, so the one which is written in blue or violet appears little more higher, okay, compared to the one which is red.